Hello and welcome to Geek. Today's video is how science works. In every science textbook you'll ever pick up for secondary or post-16 education, you can almost always guarantee that there will be a how science works section. Understandably, as the scientific process is an integral part of science. But my problem with this is, it's oversimplified to the point where it presents science as a dull and overly structured monster. Now, science is already shown to be intimidating enough with the hefty textbooks in libraries, but coupled with this, it would scare away even the most curious of students. So in this video I want to explain the scientific process in its true form, and how it's used in the real world. The aim of science is to explain how or why things happen. They do this by asking questions, suggesting answers, and then testing them to see if they're correct. That is the scientific method in summary. But really it's all interchangeable and builds on itself, so rather than a step-by-step guide, it fits into itself working as a nearly continuous cycle. So the main part is testing ideas, so we'll put that right into the middle with a nice big circle around it. But to get to that point, we generally learn new things and we come up with a new idea. So let's put that up here. We'll call that innovation. When we test ideas, we also get feedback from the scientific community, so let's add a feedback section. And from testing ideas, we also get the benefits, like smaller batteries, so let's add a benefit section here as well. Now when I say it's all interchangeable, I really mean it, which makes it difficult to find a place to start. For the purpose of this, let's start in the innovation section. So you start with some sort of a motivation for going into that system, be it new technology, a surprising observation, a practical problem, or just general curiosity. So we have this motivation, and we're led by it into the innovation section, and what happens in here can happen in any order, and can loop around until you get to a point where you can test something. Generally, what it consists of is research. So you look into the problem and possible solutions. You ask questions, you share ideas. It's really a discussion stage. Most scientists work in groups, so they openly discuss the possible solutions, and they question others, and they decide which solution is best to go forward with. Students tend to do the same thing with their teachers when writing reports. It's usually about this point when you come up with a hypothesis. Then we get to the testing stage, so we gather the data and we compare the expected results to the actual results, and from that we can tell if it's supportive, contradictory, surprising, or inconclusive. The surprising ones tend to lead to a new hypothesis. So after analysing data, the results are shared. Scientists do this using journals and joining other scientists in a similar field to discuss the recent discoveries. Scientists are actually one of the most highly travelled professionals because they go to events worldwide to participate in discussions like this. Before it's published, the journal sends it off to other scientists and asks them to replicate it and to see if they get similar results and draw similar conclusions. This prevents people from making up their own data, and it regulates the scientific community. Once it's published, other scientists come up with new ideas and questions and even build theories on your work. Then we get to the benefits section. So the benefits of science could be to improve technology, to address societal issues, solving everyday problems, building knowledge, and informing policy. The informing policy part is particularly important for discoveries like CFCs damage to the atmosphere. If scientists couldn't inform policy, we would still be using CFCs even though we knew what it was doing. It's the same with asbestos. So now I just want to prove it's a cycle. You can start off with the benefits section. Say your aim is to improve technology, like making a smaller battery. You start there and you go into innovation, you research, you discuss, you come up with new ideas, and then you form a hypothesis. Then you test this and you check it all works, and then you end up at feedback. Or you could start at feedback. Say someone published a paper and you have a better idea. Then you can go to the benefits or the innovation section and start the cycle again. And then there are cycles with themselves. Say you're testing something and you go to feedback and you get really bad feedback for it. You go back to the testing to try and improve that. Or you're testing aiming for a smaller battery and you either get it or you don't get the exact size you want. So you leave the benefit section and you go back to testing and you see if you can make it even smaller. I hope I've shown you how it all interlinks and how it's not as linear as textbooks make it out to be. If you went through this process and you discovered something new, or a better way to explain something, like the electromagnetic force, it's accepted until someone can come up with a better solution or explanation. We accept what evidence backs up. So if you came up with electromagnetism and the results proved it, it would be accepted, just as it is today. But if someone found a flaw in it, somewhere where the data and the expectation doesn't add up, it can't be accepted as a final explanation. And it's got to be improved. And that's the brilliant thing about science. It's always self-improving. Sometimes you can't do an experiment and instead you have to do a study. An example would be to answer the question, does drinking chlorinated water increase the risk of cancer? In this case, you'd have to get two groups that are as similar as possible, like ages, genders, diets, and stuff like that. And then you have one group drink only tap water and the other only pure water. And then over time, you record the number of cases of cancer in each group, and then you compare it, and that's your study, and you draw conclusions for that. So that's the scientific process. I hope I did it justice in this explanation. Thanks for watching, and I look forward to seeing you next time.